Hello everyone, this Keep Talking project update is all about the physical circuits. You probably have seen that many of my previous videos have involved a lot of demonstrations of the modules working on breadboards, which is great to show the game working, but it can be a little hard to see what's what, the layout of the components on the breadboard isn't clear, and it just looks really messy having wires going everywhere. Now obviously the project wasn't going to stay on the breadboard forever, but after 2 years I hadn't really made much progress on this front. I had attempted to move on to using circuit boards quite a while ago, but I was limited to what I knew, which was essentially just the hand soldering through-hole devices. This turned into a challenge for me for quite a few reasons. Firstly, I'd have to draw up a careful schematic for the board layout, and that was one per module. Then decide between perf board, with individual copper contacts, or strip board, with strips of copper per line, and that depended on how I could arrange the connections for each of those board layouts. Next, I'd have to trim the board to a standard size so they could be slotted into the module boxes, and this wasn't easy to do with much accuracy. Then I'd have to spend a lot of time cutting wires, soldering components, and testing continuity. And my soldering isn't the best, so it wasn't an easy job, and frustration would easily set into this very long task. Now I did end up doing one circuit board just to show what I could do. But the final issue really was the size of the board. Needing to plug in the ESP, the can breaker board, and maybe other similar items like this made the boards quite tall. And I realised that with this board, which was intended for Simon, it wouldn't actually fit where I'd intended it to sit at the bottom of the module, which is why this example has it up against the side, where I was really struggling to find some room for it. Those arcade buttons I'm using for Simon are so long that they would have pressed up against the boards at the bottom. Now I could have attempted to have made these boards thinner, but I suppose I was really looking to avoid having to hand solder dozens of similar boards. And at that time I didn't have an alternative, so I sat on it hoping to improve my skill or for another solution to come along. Well, I stumbled across a few videos of people designing their own printed circuit boards and having them manufactured. And after dismissing the options that required etching boards by hand with pretty awful acid, and the mega expensive home PCB factories that did it all for you, I dug a little deeper into PCB manufacturing companies who, to my huge surprise, turned out to be pretty accessible to the public and not prohibitively expensive as well. So I got started watching more videos of PCB design, read some books, and muddled my way through my first design, which I partially did on stream. This was surprisingly easy for a total beginner, obviously not super easy and straightforward, but after learning a few rules to bear in mind and continually coming back to the design to refine it, I finally had my first design ready to go. This design is essentially an ESP32 dev board, much like the ones you can buy. It's simply an ESP32 with most of the pins brought out into connectors, plus the CAN circuit. Rather than dive into specific designs at this stage, I thought I'd just keep it really simple so I can test the overall design and just prove that it would work. And this dev board style design would mean that I could test any of the modules that I had on breadboards so far. So I sent the design away and forked out a little extra for assembly since I have no surface mounting soldering tools, and my previous hand soldering left me wanting to just avoid doing this myself at all costs. And here's the board. This looks incredible to me, just seeing my fairly simple design in a sleek and professional package. Super happy about it. I managed to get all of the surface mount components assembled, leaving only the through-hole items for me to finish off. Thankfully, doing a few connectors wasn't too much trouble and really reduces the workload on me when it comes to full PCB production. As I set the PCB up like a dev board, all I needed to do was attach the arcade buttons and lights and simply plug them into the correct header. This was a little awkward, but there's just enough room in the box. Now the connector in the top right is how the board's programmed. I'd wanted to replicate the ESP dev boards you typically see, which have a USB port and so require a USB to UART chip to translate the messages. I had struggled designing this part of the circuit, but decided to scrap it altogether after discovering that the typical chips were out of stock everywhere, saved by the global chip shortage finally. I found I could replace this with an external programmer board designed by Espressif themselves. This keeps my PCB simple and cheaper, as I only needed one programmer in total rather than having to design one programmer for each board. And the programmer worked perfectly. It connected to my computer just fine, and I could upload the code to the ASP on the board. Thankfully, the serial connection also worked through the programmer, so I could keep debugging and testing that things were working along the way. So, on to testing. I used some serial connectors to hook the module up to the breadboard, so this will test the module through the serial ports, just as it would when the module was sat in the BOM case. To start, I used the debugger to send canned messages to Simon to test that the game starts, plays, stops, and there's my first problem. So this issue took quite a while to track down. The debugger was working fine, thanks to my oscilloscope for confirming that, and the cable and serial connector had no problems, yet the ESP didn't acknowledge any of those messages. After some searching of datasheets, it turned out that I'd designed a different CAN chip to the one that I chose for the assembly. This chip used a logic level pin to select the voltage it would communicate with the microcontroller. Since the chip I'd selected in KiCad didn't have this pin, the logic level wasn't set, and so the CAN chip couldn't talk to the ESP. One quick but really difficult to solder patch, and the CAN chip was back talking to the debugger. Now this wasn't the only problem with the board. There were 4 issues in total. Now this was expected as it was my first design, but thankfully there were somewhat minor issues that could either be worked around or ignored for this board's purpose of being a feasibility test. The other issues were the resistor in series with the reset button was too large, meaning the reset button does not reset the ESP. The hastily added diode on the reset line, which I added so I could reset all ESPs in the BOM if needed, was placed the wrong way around, so I can't reset that ESP with that either. Thankfully the programmer board does have a reset switch. The final problem I found after soldering a second PCB. So I thought it would be a really good test to remove the debugger and have only PCBs talking to PCBs. No external breakouts or external PCBs. So this test would be just like the modules would be connected in the BOM case. And after trying this, the canvas stopped working again. This final issue, after a lot of bug hunting, was that the terminating resistor between the CAN line was too large, another mistake of mine. The previous test with the debugger used a CAN breakout board with the correct resistors, which stopped the issue occurring, but without that crutch, the PCBs on their own could not talk. So a couple of resistors added to the breadboard, and we have our workaround. I took some time to revamp the phone app, and here we have a full test of the timer using Bluetooth and Simon, and it all works. Now we're on track to bring this project to the end. Going forward, I'm going to take this test PCB, fix up the problems I've had with it, and create some individual schematics for each module, incorporating only the pin connectors needed and any resistors, level shifters, shift registers, whatever else is needed. And I can simply copy the breadboard designs of all of the modules I've already built. At this point, these changes will be incredibly easy. And to wrap up progress beyond the PCB, I've also finished all of the CAD designs for the widgets, including batteries and useless ports. I've got more aluminium extrusion as I've decided to make the modules 5mm deeper, in part to hide a gap between the inner and outer frame, but also to give myself more room inside the module boxes. And lastly, I'm mostly using Prussament in this project, with the main colour being Galaxy Silver as a decent shade, with glittery flakes to make it slightly shiny as the metal it should really be. However, after running low, I noticed the Prusa have a new colour, My Silverness, Now thankfully they have a comparison of this against Galaxy Silver, so I knew this was a perfect colour for this project. It has a slightly more bluish tint like the game, but also instead of glitter it has a stronger glossiness which makes it much more reflective. After a test print, I'm quite impressed it prints so smoothly. I really thought that any small bumps and artifacts would show up due to the glossiness, but it works really well. Unfortunately, the colour change means a lot more reprinting, particularly since I just finished doing the case panels and widgets, but really I'm happy to spend more time to get a better end result. And that's my entire update. That took a while. I do think I put too much detail into these videos sometimes, but it just shows how many decisions, how many bits of trial and error, and how much time goes into seemingly small changes that you see in these videos. I'm fitting this in alongside my full-time job and still consider myself an electronics and microcontroller beginner after 2.5 years. So although I'm sure someone else could do this much quicker than I, it would still take quite a lot of hours and a lot of thought to push this project forward. I'm also, as I hope you've noticed, putting more effort into these videos. I never really intended for them to be very fancy, just simple updates on a small little thing that I'm working on, but as this project grows ever more complicated and detailed, so too should the videos to capture all that hard work. Anyway, thank you so much for watching. I'd love to hear what you think, so either leave a comment here with some questions or encouragement, or pop on the Discord server for some keep talking real life builds and have a chat with me and the other builders with similar projects and see what's going on. Catch you all next time, where I'll hopefully have the case built for the final time, more modules fully printed with operational and specialised PCBs.